Okay, so all right, so in static routing, you have to tell the router manually where the network is and how to get there, meaning what interface to use and which router to go through. Okay, and you have to do it manually with IP route command. So you have to specify the network ID, network ID with the subnet mask, and the interface. Either it's the next hop IP address or the name of the interface. So you have to do it manually. So let's say if you have 20 different networks, 20 subnets, which is these days is possible. Okay, even in a mid-sized company, even in our department, we have how many rooms? For we have 15 different subnets in just our department, very small department, right? So yeah, so and as you learned yesterday, you have to configure each router. So if you have 20 subnets and you have, let's say, four routers, each router connected to 5 different networks, so you have to configure each router, which is not a big problem if you just have to configure once. Why static routing is not a good solution? In what situation? Those of you who were there yesterday. So, okay,
networks,
A,
on big networks.
exactly, but when the network is big. So even, let's say the network is really large. So initially you put time to configure all your routers. Let's say it takes 2, 3, 4, 1 week. But that's not the only problem. Even if you configure it initially and you took time, because dynamic static routing is faster than dynamic routing. So you took time to configure all your routers, but the real problem you will have with the static routing when there's a change in the network. Okay, what sometime the network is down, an interface goes down. Either something wrong with the cable or something wrong with the interface itself physically, so it goes down. That means that network is not available. So what you have to do, what should be done is that network should be removed from the routing table, meaning that network is not no longer there. If you don't remove it, what is going to happen? Routers will keep routing packets to that network, but that network is not available. So what happened is these packets, they get lost and they create a loop. This is advanced stuff I'm telling you, okay? So it creates a loop and that can bring down your whole network, okay? A lost packet is not good in any scenario. So the same thing, a lost routing packet will just loop around the whole network and it can cause collusion and it can cause the disruption in services. So that so if the network is not available, what you have to do in static routing, for example, you have to go to each router and remove that route. That takes time, right? And maybe you won't even know that network is down on a timely manner unless you see your network is already down. Okay, so that's the biggest problem with static routing in a large network. Okay, in a dynamic routing, as I explained yesterday, the if one of the network is down, dynamic routing protocol will automatically remove that network from the routing table. Okay, So that's the biggest advantage of dynamic routing. Even so, even in a smaller network, people prefer, some network engineers prefer to use dynamic routing. All right. So that so there so dynamic routing, in dynamic routing you use a routing protocol, which is a software, just like you have a routed protocol. For example, TCP/IP is a routed protocol. A routed protocol is a protocol that is used by every single device on the network. So any device that is connected to the network, you needs a routed protocol. So this is the term, remember. Maybe you will be asked in a job interview, okay? A routed, so TCP/IP is a routed protocol because it's used by routers. It also used by your operating system. These days, your phone, your smartphones are just like a computer, mini computer. And what other devices uses are directly connected to the network? Uh, am I missing something here? What device uses IP address? Okay, voice over IP. Okay, and yeah, network printer. So they all, these devices use routed protocol, and in this case, well, today the most popular routed protocol is TCP/IP. Okay, routing protocol are only used by routers to exchange routing table. So remember that. So that's the difference. So TCP/IP is a routed protocol that is used by all the devices, and then you have routing protocol that are only used by routers to exchange routing table. So the routers use both routed protocol, TCP/IP, and the routing protocol. Okay. So there, and what is the and what the routing protocol do is they create routing tables. So it's a software, right? And their job is to create routing table, as opposed to when you have to create routing table statically. But if you use a routing protocol, that will do it for you. But still some configuration involved. Don't think, okay, you just, there's one command, you enable it, and that's it. It will take care of everything else. No, there's still a little bit of configuration involved. The real benefit of dynamic routing protocols are, when you enable it, they just take care of themselves, the whole routing process. But configuration is still involved, little bit of work. Okay. So there are many different types of routing protocols. Just like routed protocol, there's TCP/IP. There's what else? Apple Talk, and they're not being used anymore, but there are different type of routing protocol. So it's a software that you have to enable it. Mostly, so there are different type of routing protocol. So one is very popular is RIP version 2. This is the latest version of RIP. It stands for uh, uh, oh man, I forgot what does it stand for. Routing I protocol something. Okay. So this is very popular. It's mostly, you guys will be working with RIP. If you're working in a medium to small to medium sized company, most of their routers will be running RIP. Like in our department, we're using RIP protocol. Then you have RIP version of IP version 6, RIP NG, and then there's other routing protocol, are EIGRP and OSPF and ISS and BGP. Now, what is the difference between all these routing protocols? So as you can see here, it says distance vector and link state. and there's a path vector. So what is this distance vector and link state? So what is the main job of the router? So they connect multiple network, and what they do after once they connect multiple network. Anybody? Once once they connect multiple network, what they do after? Why they use routing table? I've explained before. They choose the best path, right? They choose the best path to go because there could be multiple path uh, to a specific network. So what the router does, they choose the best path. So I gave you the example yesterday. So let's say from Lachine to downtown, you have many different routes. Okay, you can take Highway 20, or you can go to Cordelias, and you can even take Lakeshore, right? There are different paths. For some routing protocol, the best path is the shortest distance, the shortest path. Okay, so which is the shortest route in terms of distance to go to downtown? Is it 20 east? All right, so if it's 20 east, a distance, so what so distance vector routing protocol will always use the shortest path no matter what. So even though if there's an accident, if there's delays on if there's a traffic jam on highway 20, they will always use the shortest path. So these are called distance vector routing protocol. So there are two distance vector routing protocol, RIP version 2 and EIGRP. Okay. Then you have link state protocol. These are more advanced protocol. What they do is, so let's take the analogy of going from Lachine to downtown, multiple path. Link state protocol, what they do is, if there's an accident on highway auto route 20, they will reroute the packet to other path, even though they're longer in terms of distance, but at that time, because there are delays on highway 20, they will reroute. They will choose the best path based on the link status, which is the fastest link. They will not just choose for them the best path is not just the shortest distance. It's the speed of the link, how much traffic is between the link. Okay, so that's the link state routing protocol. So that's the link state routing protocol, and one of the most popular link state routing protocol is OSPF, Open Shortest Path First. Okay, then you have, and there's ISIS. These are all advanced. We are not going to. So those of you who wants to pursue CCNA later on, you will learn about OSPF. But in this course, we only cover RIP. And then you have BGP. BGP protocol is run between ISP routers. So the internet is the combination of multiple ISPs that are connected to each other. So they have these routers. Let's say Videotron had this big router that is connected to Bell's router, and the Bell router is connected to AT&T router. And they're called border routers. Okay, and BGP is used to route packets between border routers. So there are three. So these are the three different type of protocol: distance vector, link state, and path vector. All right, so we will only focus on distance vector in this course. So, and we will cover how to configure RIP. Okay. So there's an updated version of RIP, which is RIP version 2, which is better than RIP version 1. It just supports larger network. Okay. And so yeah, I explained. And for a very large network, a network that has multiple link, maybe there's a link 1 gig per second link, then 10 megabits per second link, and then 100 megabits per second link, because the link could be different. For that is the protocol is OSPF, Open Shortest Path First. Okay. And this ISIS is for intermediate system, meaning network from different organization are connected. And enhanced uh, EIGRP is a Cisco proprietary protocol. It's a distance vector protocol, but it's Cisco proprietary. Yes, go ahead, Sean.
Quick question. What's the difference really between RIP and OSPF?
What different? Okay, for
Okay.
RIP, for RIP, the shortest path is the best path is the shortest distance. Okay. For OSPF, the best path is not just the shortest distance; it's the path that is the fastest link or less traffic.
Oh,
So
with the highest bandwidth, pretty much, right?
I'm sorry.
With the highest bandwidth, is that?
Exactly. So let's say for the link state, okay, let me give you an example. So if you have a again, the easiest, I will use the analogy, okay, of real world analogy. So you have to go from Lachine to McGill, from the center to McGill, right? What are the two paths you can take, Sean? Sorry, two route.
Oh, say that again, please.
Okay, let's say if you're traveling from the center in Lachine, our school, to McGill University, what are the two route you can take?
Oh, I remember your analogy from yesterday. Either the 20 or the 40.
40. Okay, in terms of the distance, which one is the short the fastest in terms of the distance?
The 20.
Faster, eh?
The 20.
20. So if you're using distance vector routing protocol, okay, it will always use 20 no matter what. Even if there's an accident on 20, it will always use 20, RIP version 2. If you're using OSPF, it will monitor both route. It constantly monitoring highway 20 and 40, and it will see, oh, there is in highway 20 there's more traffic. Okay, the traffic is slow, and then it will use highway 40 even though it's a longer distance, but it's the best path at that moment. So that's the difference between link state. So on a network, you have multiple paths to go to a network. So if there's one path is 10 megabits per second and one path is 100 megabits per second, distance vector will use the 100 megabits per second.
So, from my understanding here, the RIP would be better for a static um, routing, and then OSPF for dynamic. Is my
No, RIC is dynamic routing protocol. It's not static. They're both dynamic protocol. They use different technique to choose the best path.
okay?
RIP is mostly used for medium to small businesses. OSP is used for very large network, because OSPF has more overhead. It has to monitor traffic all the time, and the packets that it exchange are larger. So It in some case, if it's not needed, you should not use OSPF. Okay, so RIP, the best path is the shortest distance. Link state, the best path is the fastest. Whatever the link, the fastest link, so that's what link state chooses. All right. Now, how all these, so in a dynamic routing protocol, you don't have to create routing protocol. Static route. You don't have to create routes manually. What they or you don't have to if there's a change, you don't have to go to each router and modify the routing table. Instead, dynamic routing protocols, they update each other. So once you configure the dynamic routing protocol, any of them, either OSPF or RIP, what they do is they exchange information with each other. So let's say you enable RIP on R1, R2, and R3, right? Constantly, I don't remember, like every few seconds, they're updating. So let's say if R1 is connected to a network, well, you don't see it here. Let's say it's connected to two network. If one network is down, R1 will update R2 that this network is no longer available. And actually it will update to both R1, R2, and R3 because they're both directly connected to R1. Okay? So they keep, that's why, when you use dynamic routing, it uses more memory, okay, and it also uses network bandwidth because they're constantly updating each other. So these are the packet, it comes with the cost. And they also use CPU power, CPU processing power. But anyway, these days the routers are, RIP is nothing for modern router. It's not it's not that resource intense protocol. In early days, when memory was much more expensive, the CPU, PU were much more expensive. Then so it was a concern. Okay, you have to think about using dynamic routing. But these days, RIP is very lightweight. Okay, all right. So they create a database, and then they exchange this database with each other. All right, all right. So dynamic routing protocol use dynamic routing, if for example, is the best choice for large networks. Actually, it is impossible to use static routing. Those of you who understood static routing yesterday, can you imagine? All right, even you put, okay, a month configuring all these router with the static routing. Only this router is connected to how many networks? Let's see. Okay, can somebody tell me this router is connected to how many networks? Do you see my do you see the cursor? What I'm pointing at? How many this router is connected to how many networks? I have gone through this many times.
Four.
Are you sure? The answer, no, it's not four, it's more. So there's a hint. How did you come up? Look, if you're not going to understand this, there's no point for me to talk about static routing, dynamic routing. The first thing is to configure static and dynamic routing to identify how many networks a router is connected to. So if you guys don't understand it, there's no point just going further. Seriously, you're wasting your time and my time.
Like seven, then.
Exactly, it's seven networks. Look, one, two, three, four, four switches. These switches are connected to the interface, right? Each interface is a switch. Then it's connected to, so one, two, three, four. Then it's connected to this router, five. Then it's connected to this router, six. And then it's connected to this router, seven. Okay, all right. So imagine just one router here is connected to seven networks. So you have to create seven entries in just one router. Then this router, you have to go to this router, that is static routing. Impossible. And imagine if one of the network is, if the link between this and this router is down, okay? Something happened to the physical link, or the cable broke, whatever. It's underwater and a ship cut the cable. So this network is not available. All these router has to be in to modified, okay? Which is almost impossible in static routing. But dynamic routing, they will update the whole network automatically. Okay, so that's when you need uh, 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 that's why you need dynamic routing. All right, modern networks uses the combination of both static routing and the dynamic routing. What happened is here, this is the example. So here you have R1 and R2. This PC access the internet through R2. R1 is not directly connected to the internet, as you can see, right? So PC1 can access PC3, but uh, to access internet, there has to be a default route configured on both R1 and R2. And the default route are always static route. There's no dynamic default route. They're always static route. And I don't know, I'm not gonna even attempt to test how much you remember, because yesterday we talked about how to create a default route, okay? So that's the typical mm, mm, configuration you will see in most of the businesses. You'll be running RIP, okay, and you will have one static route that is connected to the internet. But it doesn't mean you will. That's the only time you will use a static route. Let's say if there's only one. In this whole network, you can easily use a static route. You don't have to use RIP, even though it's very low overhead, but you can easily use static route because there are not many networks. You know, R1, you have to only configure two networks, and the default route three increase, which are not much. Okay, and same thing R2. Well, in R2, yeah, two and three increase. All right, we already talked about this. What are the static routing advantages and disadvantages? So just read that again. We already, and we also talk about dynamic routing advantages and disadvantages. Advantages. Anyway, so yeah, quickly, they're suitable for topologies with multiple router, multiple links. They can be complex to implement, and the biggest disadvantage is they use resources. They use bandwidth, CPU, and I think that's the, if you can call it, disadvantage. But of course, if you're going to have a large network, you will have at least decent routers that are capable of running dynamic routing protocol, especially this day and age. So I don't even call it disadvantage. Okay, it all depends on the situation. So if you have a small network, there's no reason to. If your network is only consist of four subnets, there's no reason to use dynamic routing. Just use static routing. Four entries are not It's not going to take that long to create 4 entries. Okay. All right. Now we're going to talk. So now we have covered what is dynamic routing is. Okay. You use a routing protocol, either RIP, OSPF. There are many different type of routing protocols. Now we're going to learn how to configure RIP version 2. By the way, these routing protocols are embedded in the operating system of a router, whether it's a Cisco router, and they're vendor independence. They're not these routing protocols are not owned by one company. So you're gonna see these protocols in Juniper network devices, YY devices, Netgear devices, Cisco devices. Okay, and they are embedded in the operating system, just like TCP/IP is embedded in the operating system. So all you have to do is you just have to enable it in the operating system. So here, so configuring is very easy. Okay, so here it's a global configuration command. You go to the global configuration config T. Okay, do you guys see my screen properly? Can you read it?
Yes.
All right, so you go to global configuration. The command is router, and RIP is the protocol that you're enabling. So let's say if you're using OSPF, you type router OSPF. If you're using EIGRP, you type router EIGRP. Okay, so you configure. So in this case, you're enabling RIP. So router RIP, and then it will take you to the sub mode where you can configure your RIP protocol. Okay, and let's see. And oh, sorry, and if you want to disable RIP, so let's say RIP is running on your router and you want to disable, you want to enable some other protocol, no router RIP. That's all. You go to the complete the global configuration command and you just type no router RIP. Anyway, so you guys know that this is true to any other configuration that you wanted to remove. If you want to remove an IP address, just type no IP address and the IP address. Okay. So the same thing. If you want to remove RIP, just type no router RIP. And here, if you type the question mark, it will give you all these commands, all these options that you can configure in RIP submode. Okay, all these. All right. So when we're configuring static routing, what is the first thing we need to know? It's a question. So those of you who were there yesterday, especially, you should be able to answer. What is the first thing you need to know? So if I'm configuring R1, and I told you many times, what is the first thing I need to know to start the configuration?
Which network is going to?
Which network are not directly connected?
Okay.
Am I right? Right, Gagandeep?
Yes, sir.
Okay. So R1, what networks are not directly connected to R1? How many networks, first of all, are not directly connected to R1? Again, it's a question. Eh? 3 networks, perfect.
Not directly connected.
Not directly connected, yes, not direct. 192.168.3.0, 192.168.4.0, and 192.168.5.0. So this is what we have to we determine when we're configuring static route, and then we have to tell the router that, oh, these network are existed and how to get there, right? In dynamic routing, it's the opposite, and I will explain. In the dynamic routing, you first thing you need to determine what networks are directly connected to me. So if I'm configuring R1, so what networks are directly connected to R1? How many, first of all?
Two.
Only two networks are directly connected to R1. Very easy. 192.168.1.0, 192.168.2.0. Simple enough, right? And so once we enable router rip, we use the network command. Okay, this is the command network, and we use the network ID of the network that are directly connected. So one is router rip. We in it now we are in router configuration mode. Network 192.168.1.0, and then network 192.168.2.0. Why we choose our own network? Because as you remember, dynamic routing protocol updates other router. Okay, so once you do this, R1 will tell R2, hey, I am connected to these two network. So if you ever have a packet with the destination address of any of these network, send it to me. Okay, and so that's why then you go to R2. How many networks are directly connected to R2?
Three.
Three. Perfect. 192.168.2.0, 192.168.3.0, and 192.168.4.0. So guess what? What are you gonna have here? Can somebody tell me? So you go to R2. Let's see if no, there's only one is up. So you go to R2. What are you gonna type here after? So you're gonna enable router rep, and then tell me the first entry.
IP root.
Not we are configuring dynamic routing, Sean.
It's gonna be after router rip network 192.168.2.0
Perfect.
and
Next.
next network 192.168.3.0 and the next is 192.168.4.0.
Excellent. You have to advertise your own network. Okay, Sean, I don't know where you come from IP. We're talking about dynamic routing, and this is how you configure dynamic routing. Now, R3, how many networks is directly connected are directly connected to R3?
So
Exactly. 192.168.4.0, 192.168.5.0. So we will go to R3 and we're gonna type router rep, and then what?
netport 4.0 and netport 5.0.
Perfect. That's it. And you enable rep. Now after all these router will update each other. So R1 will tell R2, hey, listen, if you have any packet for these network, either 192.168.1.0 and 192.168.2.0, send it to me. R2 will tell R3 and R1, because they're both connected to R2, hey, if you have any packet destined for 192.168.3.0, send it to me. Okay, and R3 will tell R2, and therefore R2 will pass this information to R1. Hey, if there's any packet destined for 192.168.5.0, send it to me. Okay, how many people have raised hands? Okay, go ahead, Gagandeep.
So if we have a like big network, like this is only three routers. If we have like we have too many, so we have to
Yes,
Okay.
you have to go and do it in every router. So here there are 7 network, right?
Yeah.
Remember, this router is connected to 7 network. You have to go to this router and you have to enable RIP, and you have to specify all the network. You have to go this one, this one, this one, this one, every single router.
Okay.
And but you know what? If that is your job, okay, region 1, region 2, region 3, region 4, and you'll be for sure you'll be earning at least $250,000 a year. So that wouldn't be a big because it's a huge network, different region, okay? Yes, you have to do anyway in a network like that big. I'm sure it's not using RIP, it's using OSPF. Yes, Nicholas.
The same steps with OSPF?
The same with OSPF?
Yeah.
No, OSPF. Okay, you have to enable OSPF with this command router OSPF. Then yeah, you have to specify network. But also there's some additional configuration because OSPF use more data. So there's called neighbor discovery but it's not that complicated. The basic idea is this. All right. So this is simple. This is how the how you configure RIP. And even look, the network, it doesn't matter how many routers you have. Again, you have to understand the concept. If you understand the concept, if I just told you, if you understand that, even if there are 200 routers, you're able to configure it. That's all you need to understand. So like say, let's go back to this example. So let's say you're in this router, right? Just tell me how this router, that's the main thing. That's why, and I've been repeating this for many days, not even in this chapter, even module 15, we cover that routing. Okay. So this is, otherwise you will not be able to configure either dynamic or static routing if you don't understand this concept. All right. So somebody tell me this router, okay, you can, how many network is connected to?
6.
Let me see. 1, 2, 3, 4, 5, 6. Perfect. So let's take the example of this router. All you have to do is go to this router, type router rip, and the command is network, and with the network ID. So let's say these 6 network are 192.168.1.0, 2.0, 3.0, 4.0, 5.0, 6.0, right? And all you have to do is just go there, type 192.168 network 192.168.1.0, 2.0, 3.0, 4.0, 5.0, and 6.0. And before somebody asks me, I'll already tell you, there's no one command that will include all these 6 network. You have to do it one by one. Okay. If somebody, because yeah, there's always somebody ask, okay, but can we do it with one command, all these networks? No, you have to do it one by one. And that's it. It's very simple, dynamic routing. You just have to determine. So here, if you go to this router, it's connected to, again, 1, 2, 3, 4, 5, 6, 7. Okay, so if the network ID is 192.168.1.0 to 7.0, all you have to do is you have to go to that router And now you will have 7 entries. That's all. Then you go to the next router, do the same thing, see what networks are directly connected, go to the router global configuration mode, network 192.168, and that's it. Network is the command, and that's all. Now, once you configure it, you have to verify, right? One of the command is show IP protocol. It will tell you what routing protocol is enabled. So in this case, routing protocol is RIP. This is enabled. So if your routers are not routing and you want to troubleshoot, so you type show IP protocol and you don't see any protocol that is enabled. Okay. So you have to enable the routing protocol. And here, oh, sorry, yeah. So they send updates every 30 seconds. Okay, next due in 60 seconds. So these routers, when you enable RIP, they're sending each other updates every 30 seconds. That's why they create they increase, they use the network bandwidth, they increase the traffic. But again, in today's network, the connections are fast, so that's not a big issue. Okay, it was in early days. So they're invalid after 180 seconds, hold time 180, flushed after 240. So they keep the update and they flush it after 240. But anyway, all this information you needed if there's something wrong in the network, if the network is down or if the network is slow, it could be related to RIP updates. So you go there and you see if it's sending the updates or not, when was the last update, if it received the right update or not. Okay, and here what are the interface that are used to send updates. Okay, so for example here, this is connected to G0 and S0. So it's sending updates through these interfaces, S0 and G0, S0. R2 is sending updates to what interfaces? S0, S01, and G0. And R3 is S01 and G0. Okay? It's sending updates through interfaces. And here it also tells you how many for what network is routing for. So you see, you configure these two network, 192.168.1.0 and 2.0, and here you can see it. It's routing for these two network. Yes, go ahead.
I don't quite understand. What are they updating?
They're updating about their network. Router is telling R2 that is connected to these two networks, 192.168.1.0. So this is what you so what, let's say if this network is unavailable, 192.168.1.0, maybe this switch is down. Okay, this network doesn't exist. Router will tell R2, okay, I'm no longer serving this network, so don't send me any packets destined for 192.168.1.0, just discard it. And I just explained it about the routing loop. If it doesn't update R2 and R3, what is going to happen is, let's say if any user from this network trying to access a host on this network, R2 will send this packet to R1, but R1 will does not have this network available, but all these router thinks it is still available. So the packet will, is called will loop in the network, and that can create a problem. That's why this update is important. So if this network is not available, R1 will update other routers that is not available. Don't send me any packet for this network, just discard it. All right, the IP root command with begin gateway plus resort is not set. Okay, begin gateway means default root. That's why it's a new command. All right, first of all, you can use pipes, this pipe, to filter the results of a command. Okay, and it works with any other command, not just this. So if you did just type show IP root, because that's what I do usually, show IP root, it shows me, it displays the routing table. So in this case here, so C means directly connected network. 192.168 is directly connected. What is L means? I explain it. Can somebody tell me what L means? All right, no. Is the the IP address of the interface. Link, L stands for link, IP address of the interface. So this is the network and this is the IP address of the interface. Here, oh, is the IP address of this interface, 192.168.2.1 or 1.1. Okay, that's what you see, 1.1 and 2.1. So the C is direct, and R are the network that are learned from the RIP protocol. Okay, so you can see there's 3.0 network, 4.0 network, and 5.0 network. Where they came from? Hmm? From these two routers. They tell R1 that, okay, listen, I am connected to these networks, 3.0, 4.0, and R3 is 5.0. This is what they're updating. Okay, Nicholas.
Roger.
All right. Okay, every 30 seconds. So let's say if a user from 1.0 network cannot access a server on 5.0 network, what you can do is just go type show IP root, one of the way to troubleshoot, and look at if you see that network 5.0 network in the routing protocol. If it's not there, that means there's something wrong. You have to troubleshoot. Either you did not configure R3 with RIP protocol, or the network is down. Okay, but this is something you have to configure. Maybe the link is down. So these two commands are this is what all the network administrator use, or I use mostly: show IP protocols and show IP root. Show IP protocols will tell you what protocols is being used, what networks are being advertised, and here show IP root will give you the detail of all the network, what uh, 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 what networks are learned through routing protocols and what networks are directly connected. All right, in older, any router that is 5 years old or maybe more, even 6 7 years old, have RIP version 2. Okay, which is the better. It has it supports more network. Okay, but in case if you're working with an older router, you have to enable RIP version 2. In newer router, when you enable RIP by using router RIP command, by default it uses version 2. But in older router, you have to specify RIP version 2. So there's one more command. So here, router RIP, in all the routers that we have in the lab, by default they use version 2. So when you type router RIP, it will automatically enable RIP version 2. But if it's an older router, the next command you have to type version 2. That's all. So if in the exam it asks you, okay, to enable RIP and use version 2, that means you have to use this command as well, version 2. Okay. And once you and you can tell which version is being used by using show IP protocols. Here you see version 2, receive version 2. Okay, routing protocols to minimize the entry, routing entry. What they do is they summarize the route. So if they're in the same uh, if they have the same subnet ID, like for example, this one had the 5.0 network and 4.0 network, they have the same 24-bit subnet. So what they will do is they will summarize to one network automatically, okay, which you can disable by using no auto summary command, okay. So because in some cases you don't want this, you don't if you especially if you subnetted the network, you want each network to be identified separately without summarization. Anyway, summarization is an advanced topic that is used in very large network. Anyway, in a small network, you see there's only two other networks, there's no need for auto summary. Okay, what is the purpose of the update? Why routers send update it to other routers? What is the purpose?
To maintain knowledge of the state of the connection currently.
To know what network they're connected to, right? So they can, so R1 is telling R2 that I'm connected to these two network, 1.0 and 2.0 network, right? So whenever you have a packet for this network, send it to me, right? Am I right?
Yes.
Okay. Because you have to understand this to understand passive interface. That's why I'm asking you. If you don't understand this, then you won't understand passive interface. So that's the whole purpose. R2 is telling sending R3 update that, okay, I'm connected to 3.0 network. So if you have a packet for this network, send it to me. And I'm going to route it to this network. Now, in a case of switch is not a router. It does not route packet. What is the purpose of sending update to this switch? It's useless. Am I right? Switch does not route packet. It's not connected to any. It's not a router. So sending update to the switch actually is useless, and it just create unnecessary traffic on the network. But the thing is, when you enable RIP, it sends update to all the interfaces. Either it's connected to the switch and it's connected, or it's connected to the router. So what you can do is, to conserve network bandwidth, you can stop update on a specific interface. So in this case, any interface that is connected to the switch, you can stop the update by using this command, passive interface, and name of the interface. So when you use on R1, you go to the router RIP mode, just type passive interface which is G000, and this will stop router 1 sending update to this switch because it's useless. All right. What else on R2? What are you gonna do? Same thing. R2 is connected to this switch G000. Just go to R2, router rep, and passive interface G000. That's it. And R3 the same thing. R3 should only send update to R2, not to this switch. It's useless. So this is how you can stop sending updates to an interface. This is also part of your should be your configuration. Stop sending update to switches. Okay. Oh, this is my favorite command. It wasn't available before, but when it was available, it was good. All right, so let's recall. So R1 is connected to the internet. Okay, for all the user of this network to access the internet, you have to create a default route. So what is the command? IP route 000 S01 here, right? And the next hop IP address. What you have to do, okay, so you configure this on 1, and what else you have to do in order to make sure that everybody can access the internet? You have to configure the default route first on the router that is connected to the internet, and then what do you have to do? You have to use this command on each router. Am I right? Gagandeep, you were there yesterday. You were asking me.
Yes, sir.
Okay. So you have to now, obviously, it's a lot of work for some people. Why use this command to all the router? So what you can do, that's why I said you can use the combination of static routing and dynamic routing. So what you can do is you can only do this on R1. So you go to, because R1 is connected to the internet. So you go to R1, you type IP route 000, and then, so this is a static entry, right? Then you go to router, because you're also using router rep. You go to router rep and you type this command, default information originate. So this is the command, okay? What this command is going to do is it will send this information to R2 and R3. So you don't have to go to R2 and type this command, default route command, or R3. Instead, you can add this information to RIP update, because RIP protocol is updating every other router, right? So it will also update this default information. So that's it. The command is default information. So you create a static route, default route on the router that is directly connected to the internet. Then you use RIP to advertise this to other routers on the network. So no matter if there are 10 routers or 15 routers. Well, here there's only 2 other routers, but let's say if there are 10 other routers and all these have to go through, like in our department, only one router is connected to the internet. All the other routers in each class access the internet through this router. So we have to have this command. Or we have to go to each router and type IP route, and so this is the combination. All right, let's look at the routing table. I think we have covered in a previous module, but let's look at the now. So this is your routing table. Okay, so you type show IP route. Now you see you have the default route configured. In the previous example, we configured the default route here. So now when you type show IP route, begin with gateway, it will show you the default route. This is the default route. Network 000, that means any network. And here, S with the star means static default route. Okay. C is directly connected network. We are on R1, right? So 172.16.1.0 is directly connected. L is the link address. 172.1.1 is the link address, the address of the interface. R, the network that are learned from that are learned through RIP protocol. So you have 2.0 network. Where is it? 2.0 network, 3.0 network, 4.0 network here, and the 5.0 network. All these, and that's all. C is directly connected, which is the internet. Link is the address of the interface, serial 000, and R is learned through RIP. So this is how your routing table looks like. Here, more detail. C, directly connected. Link, identify how the network was learned by the router. So it's directly connected, it's the link. If it's static route, it says S. If it's EIGRP, it says D. If it's OSPF, okay, it will say O. And R means RIP. Okay, this is the destination network, and this is the outgoing interface, the interface that is connected to. Here, there's more detail. Route source is RIP. Destination network, administrative distance, meaning how good the network, how good the path is. Anyway, don't have to worry about this. This is the next hop. So which one is connected to? And this is the interface. Okay. And this is how much time has elapsed since the route has learned. Not very important. Okay. Since the okay, these are just the terms, okay, that are not very important. So there are different type of routes. First, level 1 routes, parent routes, child routes. So this is just the hierarchy. The main route, the main router is the ultimate route or the first route, and that is connected directly. Anyway, don't worry about this. This is not important for configuring RIP.